Okay, now we're going to work on curve sketching, and there are these three theorems that we're going to be learning. The first one is Rolle's theorem, and Rolle's theorem states that if a function is continuous on a closed interval, ab, if that same function is differentiable on the open interval, ab, and if f of a is the same height as f of b, then, that's supposed to say then, not there, then there exists one c value on the interval ab where the derivative at the c value is equal to 0. The other way to say that so the tangent line will be a horizontal line. All right, so let's look at this example. Without doing the work, let's just look at it. So at -4, we're at this height. And this is the interval, right? -4 to -2. Well, -2, so on this open interval right there, look at, there's this value of c where the slope of the tangent line will be 0. So this is the work that you would show. So you would say A, yes, f of x is continuous on closed interval. So between here and here, there are no asymptotes. It's completely continuous. And then you would say, and by the way, if the graph is continuous, then yes, f of x is differentiable on the open interval, and then f of -4 is equal to 1, f of -2 is equal to 1, so f of -4 equals f of -2. So all of these are ifs, and then here we have our then. Then, well, let's just take the derivative. So f prime of x, there's our derivative up there, or there's our formula up there. So our formula is, our derivative is 2x plus 6, right? So then we're going to remember the derivative is set equal to 0. If we set this derivative equal to 0, these each have a 2. So we're going to factor out a 2, and that'll be x plus 3. Where x is equal to -3, f prime of x equals 0. And let's see if that's true. -3, our M tangent right there is a flat line. So then our C value that makes f prime of x equal to 0 is at -3. Little bit awkward at the end, but so that's what you're going to do here. So on the interval -1 to +4, okay, yep, the graph is continuous. And I'm going to let you plot, this is continuous, so I'll just put this on. And if it's continuous on that closed interval, then it's differentiable on the open interval. And then let's see, somewhere on that interval do we have some same height? So let's put in at -1, we're here. Yep, so f of negative 1 equals f of 4. These are both the height of negative 1. Okay, so now we're going to do the derivative and set the derivative equal to 0. So negative 3x squared plus 8x plus 1. I'm going to pause for a second to factor. Okay, so this one right here is not going to factor because they're not going to be factors of negative 3 and 1. And when you factor it out, they're going to add up to positive 8. So I went ahead and plugged it in to the quadratic formula, and we ended up coming up with these two possibilities. Now, sometimes both possibilities won't work. So what you have to do is you have to plug it into the calculator and see if, when that simplifies, do they fall? That doesn't look very square. Do those values fall in that interval right there? And you can tell because this one's graphed, there is a value right there. In fact, there's two of them, so both of those work. Both the for subtract root 19 over 3 and for plus root 19 over 3. And those are those two C values right there. Just like that. All right. Okay, now sometimes they're going to ask, can it be applied? Well, then the first thing you're going to do, very first thing you're going to do is you're going to look at the interval, negative 2 to 2. Ah, look at that. There is an asymptote, so it does not meet this first criteria. F of x is continuous on the closed interval. It is not. Not continuous. Therefore, I'll put the 3 dots meaning therefore. Therefore, Rolle's theorem does not apply. I used to love those when I would get those. And that, in fact, you need to put this. Not continuous on the interval, closed interval, negative 2, 2. Therefore, Rolle's theorem does not apply. All right, I think that's all I'm going to be doing for this one. This one's going to be, actually, I'm going to show you this one because it won't matter. I'll show you. So, negative 6 to 6, this is continuous. So, first criteria has been met, which means the second criteria has been met. I'm going to simplify this. It's continuous, it's differentiable. And then, let's see, on that interval anyway, do we have any heights? Well, and at negative 6 and at 6, those are the same heights, right? So we have f of negative 6 is equal to f of 6, all right? So then we should be able to find where f of x, the derivative of f of x is equal to 0. So there should be a C value. And we can see that there's going to be something, but how do we do that? Well, we've got a quotient rule. So when we take the derivative, here's our here's our f, here's our g. So it's g times the derivative. Well, the derivative of x squared subtract 36 is 2x. Subtract f. Wow. It's g times the derivative of f, subtract f, times the derivative of g all over g squared. All right. So f times the derivative of g, which is just 1, all over g squared. Cool thing here is, remember, we're going to set this derivative equal to 0. So when we multiply both sides by x plus 7 squared, it won't matter. So we can just ignore this lower piece, and we can solve the separate piece. So this is 2x right here. So 2x times x is 2x squared. 2x times 7 is 14x. We're going to subtract x squared minus 36. So 2x x squared subtract x squared is just x squared. And then there's not another x, so that's plus 14x. Subtract a negative 36 is add 36. And then factors of 36 that add up to 14, or we have to do the, if that is not the case, then we have to do the quadratic formula, and I probably won't take the time to do that. So let's see, there's 12 and 3, no. 9 and 4, no. 6 and 6, 18 and 2. All right, so this one, you would just plug it into the quadratic. Now, you'd have to be really careful when you plug this in. When you plug that in right there, so what is that? I'm doing this all in my head. I don't know if this is a good idea. 72, that's 144. So 196 subtract 144 looks like 52. And then 52 is 4 times 13. So we have x is equal to negative 14 plus and minus 2 root 13 all over 2. So that simplifies. X is equal to negative 7 subtract 2 root 13 all over 2, and negative 7 plus 2 times root 13 all over 2. Well, we only have one place. So that, see this negative 7, and then it gets more negative. Well, it's negative 7 halves subtract. So negative 7 halves subtract root 13. So these two are over this way, well, probably in this area right in through here. Well, that's not in the interval. So we can cancel that one out, and we can say that in this case, our only x value is negative 7 plus 2 root 13 all over 2. All right, that's it for Rolle's theorem.